Good morning, and I want to thank you for this opportunity to present what we're doing at the University of Maryland Dental School. I want to thank the Faculty Center for Teaching and Learning and the School of Nursing. My talk today is entitled Using Technology During the Pandemic, Computer-Aided Design and Manufacturing, which is known as CAD/CAM, and 3D printing in dental education. As a result of the limitations posed by the COVID-19 pandemic, the University of Maryland School of Dentistry developed a series of alternative experiences utilizing cutting-edge technology to supplement the available clinical experiences of their senior dental students. Students prepared a 3-unit fixed bridge on a typodont, which is a plastic model of the teeth, and this was done under supervision of the prosthodontic faculty in a clinically relevant way. Once those preparations for that fixed 3-unit bridge were approved, the students made an appointment with me in the CAD/CAM Center. There, they learned how to digitally scan their crown preparations utilizing an intraoral scanner, design a crown utilizing the computer's designing software, and then send those digital scans to a milling machines that fabricated an acrylic crown from a block. The students next scheduled another appointment in the patient clinic where they adhesively bonded the milled restoration onto their patient's tooth. As ceramic clinical blocks are expensive, the school digitally scanned one of the blocks and 3D printed acrylic blocks costing less than $1 per block. This innovative use of 3D printing technology has saved the school thousands of dollars. The entire experience was well received and greatly appreciated by the students. Here you see one of the students working on a typodont in a clinically relevant position, scanning one of the preparations of the fixed unit bridge, utilizing a digital scanner and learning how to do that. Here, a student is manipulating the data once it is achieved. You see the upper teeth, the lower teeth, and in the center in blue is a bite, the way the teeth come together. Then what happens is once the student learns how to integrate those images, the computer will automatically correct and give you a bite and show you the clearance between the prepared teeth and the opposing teeth. Next, what the student does is he goes ahead and marks with a blue line where the margin of the preparation will be of the 3D milled crown. Next, the student, utilizing the computer software, designs the crown, and here's an image showing the designed crown. The student then checks the occlusion, that is the intensity of the bite, by manipulating the colors. Each color tells about the intensity of the bite against the opposing dentition. This image shows the various blocks that can be used to mill. In the upper left is an Emax block that costs at least $25 per block. What we did is we scanned a block and then we 3D printed it in an acrylic material, which is shown in the brown block. The other blocks are various ceramic blocks that are traditionally used in the clinic. Here the student is making sure that the crown is totally within the block so that the milling machine will mill away everything except for the crown itself. These are some images showing either the scanned premolar or the scanned molar, and making sure from various perspectives that the crown is within the block. Here again is the ceramic block on the left, which costs about $25, and the innovative use of 3D printing to create an acrylic block specifically for this exercise that costs about 70 cents. Here is the milling machine, and we have one of the acrylic blocks placed in the machine, and I'll show you in the next slide what the diamonds look like that mill the restoration. Again, here is the acrylic block, and you'll notice on the left is a flat-ended cutting diamond, and on the right is a pointed cutting diamond. The flat-ended diamond will cut the internal part of the crown, and the pointed diamond will cut the occlusal surface, or the biting surface that has grooves in it. Here again is another picture close up showing what the milling machine looks like. And here is a picture after the machine has milled the crown. Again, you see the flat end diamond on the left, the pointed diamond on the right, and you see that the diamonds have removed everything from this acrylic block except for the crown itself. And this takes about 5 minutes for this machine to mill the crown. Here is a picture of the original block and the milled crown from a top view and from a bottom view. And here is the 3 blocks. The one on the left is the original block that we scanned. The one in the middle is the 3D printed block, and the one on the right is what the crown looks like after it is printed. This shows the premolar, the smaller crown, placed on the typodont, the molar crown placed on the typodont, and this was so successful that we're going to hope to do it again in the future and potentially mill a 3-unit bridge for the typodont. Here again is the innovative use of 3D printing. I think we're the first school to actually do such a project. Here is the actual machine that digitally scans one of the blocks. And on the right is the printing machine that will print the acrylic block. Here you see in the left and the upper center, lower center, the blocks being printed from the liquid at the bottom of the lower image. You see a white liquid, and layer by layer this prints these blocks. It's an incredible technology, and it has helped us tremendously. So let me open it up at this point for questions.